Hello, my name is Chef Jansen and I'm an ecology lecturer of landscape architecture at the TU Delft. I'm going to talk about ecological networks in cities. One of the problems in getting more biodiversity in the city is accessibility. Species cannot reach suitable biotopes, or the suitable biotopes are too small. Ecological networks can solve this. First, a little bit of theory. Scientifically, the foundation of ecological networks was laid in two publications, the first of which dealt with the relationship between species number and size, and degree of isolation on islands, the so-called island theory of MacArthur and Wilson from 1967. In the second publication of Jared Diamond in the mid-70s, these research results were applied in rules for the design of nature reserves, in which he contrasted good solutions with bad solutions, like big is better than small, one whole is better than separated, connected is better than separated, and close together is better than further apart. Larger reserves not only harbor more individuals, but also more species, as this figure shows. In black are the species that are added from top to bottom because the minimum area requirements of that species are met. For example, the black-tailed godwit is satisfied with a few hectares of grassland, but a partridge needs dozens of hectares of grassland and arable land. Diamond's scheme was further elaborated in the following years. The most important components of an ecological network are cores, stepping stones and corridors. In the city, the cores are often the large parks or lakes. The stepping stones are the small parks and natural ponds, and the corridors are the verges, roadsides and banks with waterways. Examples of flowery verges or roadsides as connections on this slide. Examples of flowery banks and waterways as a corridor on this slide. An example of small parks and ponds as stepping stones on that. Example of natural parks as core areas is here a picture from. And a big problem, especially in the city, is the many barriers on roads, etc. This diagram includes 14 possible facilities that allow animals to overcome barriers. They range from tree bridges, aqueducts, tunnels, culverts, etc. As an example, the extent to which bats make use of such facilities is indicated. A red box means that a bat will not use it, and in yellow that is only used occasionally. Of course, the conditions for nature in the city are not only good. For example, environmental conditions are often problematic. There is too much noise and light disturbance. The air and soil quality is often poor. There's also a lot of disruption by people, not to mention their pets. It's clear that quiet and clean places are more promising for an ecological network. Still, there are many barriers in the city. Roads and railways, blocks of houses and waterways can be large obstacles. On the following slides, we'll show you some examples of how to overcome these. The first example is of an eco-bridge and eco-combinates in cities. In park-like environments, wildlife crossings, often combined with pedestrian and bicycle passage, can offer a solution. However, they are expensive and will only be used if an existing or planned passage can easily be expanded with an eco-facility. Much easier to make culverts or small tunnels that can be laid under a road. However, the passage must be attractively designed by a fauna edge or sandy floor. Fish ladders and bat hopovers are not common in the city. However, they are eye-catching and can contribute to the ecological awareness of cities. These hopovers are used by bats. The larger ecotunnels must be made suitable for the larger mammals that are present on the outskirts of the city, such as roe deer and foxes. Despite the technical possibilities to overcome obstacles, there are limits to these facilities. They are costly, and wide barriers, such as rivers and highways, often prove difficult to pass. As a result, everything that's not too big and flies is at an advantage, such as birds, bats, and insects like butterflies and wild bees. Speaking of that, wild bees in particular are better represented in the city than agricultural landscape nowadays. However, in fact, the fact that these species can fly and easily cross a road makes them still dependent of an ecological network, because their range is not that great. To show that species has its own requirements, we give two examples of a butterfly and a wild bee, for which I have created an ecological network in the past. First, an example of a network between the cities of Arnhem and Nijmegen in the east of the Netherlands. The species is the white admiral. The butterfly has specific requirements for core areas, stepping stones, and distance between them. See the diagram on the map here. This scheme does apply to most butterfly species. However, there are some differences. More distinctive is the bitope, as shown in the next slide. This is how this diagram is translated onto a map. It meets all the requirements of the white admiral that must be present in the stepping stone and core area. Different butterflies have different bitopes. For the admiral, the bitope is moist park landscape with at least honeysuckle for egg deposit. Without honeysuckle, this species cannot reproduce. Another project I'm currently involved in is the design of 40 hectares of bee landscape in Rotterdam. The approach is based on the bed and breakfast method, as published by Altera Wageningen University. The core area consists of at least 10 hectares of breeding and feeding area. That's the bed. And breakfast. In between, there is a connecting landscape with minimal surface requirements. Because bees are flying species, the network may be interrupted up to 100 meters. The refueling stations are small, bee-friendly places such as gardens. This is what the connection scheme looks like. There are two bitope variants, one for the species of open grassland and one for the bees of the semi-open landscapes with shrubs and trees. In our search for 40 hectares of bee landscape, we used available management maps of Rotterdam. After interpretation, we were able to distinguish between bitope that's already suitable for bees in green and bitopes in yellow that can be made suitable if the management is changed. For example, lawn that's transformed into flowery grassland. This is how we came up with a map with actual and potential bee landscapes of more than 10 hectares in Rotterdam. At this moment, we are making a choice of 2 or 3 bee landscapes and between corridors with stepping stones. A total of 70 different species of wild bees have been found in Rotterdam, including a number of rare ones. To illustrate bed and breakfast of a species, here's an example of the rich settled carpenter bee, in Dutch tronkenbij. The dots on the map are the found individuals. The carpenter bee needs nectar from composites such as marigold and daisy, that's the breakfast, and make the nest in old wood, logs, thatched roofs and bee hotels, and that's a bed. Here's a photo impression of breakfast bitopes. And here's a photo impression of bed bitopes. Thank you for your attention.